5733. If ground resonance is experienced during rotor spin-up, what action should you take? A. Taxi to a smooth area. B. Make a normal takeoff immediately. C. Close the throttle and slowly raise the spin-up lever. The correct answer is C. If ground resonance is experienced during rotor spin-up, it is important to take immediate action to mitigate the condition. Ground resonance is a potentially dangerous phenomenon that occurs when the helicopter's rotor system and the airframe resonate with each other, resulting in violent vibrations. To address ground resonance during rotor spin-up, the recommended action is to close the throttle and slowly raise the spin-up lever. Closing the throttle reduces engine power, which helps to minimize the vibration and disturbance caused by ground resonance. By slowly raising the spin-up lever, the rotor RPM can be increased gradually and smoothly, allowing for better control over the helicopter's systems and reducing the likelihood of exacerbating the ground resonance. 5734. The principal factor limiting the never-exceed speed, VNE, of a gyroplane is A. Turbulence and altitude. B. Blade tip speed, which must remain below the speed of sound. C. Lack of sufficient cyclic stick control to compensate for dissymmetry of lift or retreating blade stall, depending on which occurs first. The correct answer is C. The never-exceed speed, VNE, of a gyroplane is the maximum speed at which the aircraft can safely be flown. It is determined by the factors that limit the helicopter's ability to control itself. In the case of a gyroplane, the most important factor limiting VNE is the lack of sufficient cyclic stick control to compensate for dissymmetry of lift or retreating blade stall. Dissymmetry of lift occurs when the rotor blades are moving through the air at different speeds. This can happen when the helicopter is flying in a turn or when the air is turbulent. Dissymmetry of lift can cause the helicopter to roll or pitch uncontrollably. Retreating blade stall occurs when the blades on the retreating side of the rotor system are moving through the air too slowly to generate enough lift. This can happen when the helicopter is flying at high speeds or when the air is dense. Retreating blade stall can cause the helicopter to lose lift and altitude. If a gyroplane exceeds its VNE, it may not be able to control itself and may crash. For this reason, it is important to always fly within the VNE limits. The other factors mentioned in the answer choices can also affect the VNE of a gyroplane, but they are not as important as the lack of sufficient cyclic stick control. Turbulence and altitude can both affect the speed at which the rotor blades can move through the air without stalling. However, the pilot can usually compensate for these effects by adjusting the collective pitch control. Blade tip speed is also important, but it is not the most important factor limiting VNE. The blade tip speed of a gyroplane is typically limited to around 100 knots, but this is well below the speed of sound. 5735. Why should gyroplane operations within the cross-hatch portion of a height versus velocity chart be avoided? A. The rotor RPM may build excessively high if it is necessary to flare at such low altitudes. B. Sufficient airspeed may not be available to ensure a safe landing in case of an engine failure. C. Turbulence near the surface can diphase the blade dampers, causing geometric unbalanced conditions on the rotor system. The correct answer is B. The reason why gyroplane operations within the crosshatch portion of a height versus velocity chart should be avoided is that sufficient airspeed may not be available to ensure a safe landing in case of an engine failure. In this region, the combination of low altitude and low airspeed may not provide enough time or distance to execute a successful autorotation, which is the emergency landing procedure used when the engine fails. Autorotation requires a certain amount of forward airspeed to provide lift and control during the descent, and operating within the crosshatch portion may limit the ability to achieve and maintain the necessary airspeed for a safe autorotation. 5736. The principal reason the shaded area of a height versus velocity chart should be avoided is A. Rotor RPM may decay before ground contact is made if an engine failure should occur. B. Rotor RPM may bird excessively high if it is necessary to flare at such low altitudes. C. Insufficient airspeed would be available to ensure a safe landing in case of an engine failure. The correct answer is C. A height-velocity diagram, HVD, is a chart that shows the relationship between altitude and airspeed for a helicopter. The shaded area on the HVD represents the conditions in which a helicopter may not be able to autorotate safely in the event of an engine failure. The shaded area is created by the intersection of two curves, the power curve and the rotor RPM curve. The power curve shows the amount of power that the helicopter's engine can produce at a given altitude and airspeed. The rotor RPM curve shows the minimum rotor RPM that is required for the helicopter to maintain lift. If a helicopter is operating in the shaded area of the HVD, it means that the helicopter does not have enough power to maintain lift if the engine fails. This is because the helicopter is flying at too low an altitude and too slow an airspeed. If an engine failure occurs while a helicopter is operating in the shaded area of the HVD, the helicopter may not be able to autorotate safely to the ground. This is because the helicopter will not have enough airspeed to generate enough lift to maintain altitude. As a result, the helicopter may crash. For this reason, it is important to avoid flying in the shaded area of the HVD. If you must fly in this area, you should be prepared for an engine failure and know how to autorotate the helicopter to a safe landing. 5737. During the transition from pre-rotation to flight, all rotor blades change pitch. A. Simultaneously to the same angle of incidence. B. Simultaneously but to different angles of incidence. C. To the same degree at the same point in the cycle of rotation. The correct answer is B. The blade angle of incidence must be changed continuously to account for lift asymmetry, with one angle rising while the other falls. All rotor blades change pitch simultaneously, although at different angles of incidence, as the aircraft transitions from prorogation to flight, or whenever there is lift asymmetry.